Hi. The goal of our project is to expand our knowledge of alternative sources of transportation. We will broaden our spectrum by studying the energy sources of wind and electric power. We are going to try and make a reliable transportation device by using wind and electricity. We've chosen to use a hovercraft made out of wood and other materials found around your house. This is how we did it.
Hovercrafts can glide along rough surfaces and water because they float on a cushion of air. This cushion of air provides the hovercraft with an almost frictionless surface that they can glide along. So, a little bit of propulsion can go a really long way.
In this project, we use a Troy-built leaf blower. It produces 250 miles per hour of wind, which is enough to lift an average-sized human being off the ground. As you can see here, we have a piece of plywood. It's 3 by 4 inches thick and 4 feet in diameter. After the 4-foot diameter circle was cut, we had to cut a 6-inch diameter circle to put on the bottom of the board. Today we found out that due to cold weather, plastic and the shower curtain would freeze, creating a hard bubble which in turn popped when the leaf blower was added.
The air from the blower is going to go down through this downpipe to a hole in the floor on the underside. This efficiency sits in without the blower skirt or air chamber, and the air has the extra
fan. It both inflates the skirt, lifting the vessel about 25 centimeters, and creates thrust to propel the hovercraft over virtually any surface. Production begins with a hull made of lightweight polyethylene. The fabricator installs aluminum skids on the bottom to protect the hull during landings on rough surfaces. He screws plastic attachments for the hovercraft's skirt into pre-marked positions on the hull. The technician drills 65 holes around the hull. The fan's air will pass through these holes to fill the hovercraft's skirt. The hull consists of a thick, hard outer layer and a low-density inner layer that makes the material buoyant. It's what keeps the hovercraft afloat during stops on water. The crew now fastens the seat base and console in the front of the hull. Once it's secure, they fit the gauge panel in its slot. The team then moves to the back of the hull to install the drive belt, pulley, and the main drive frame. This pulley will transfer power from the engine to the fan. Once they confirmed everything moves freely, they assemble the fan to the main drive frame with high-tension bolts. This duct will divide the fan's air into two streams. One stream will be directed under the craft to provide lift. The other will be routed out the back to generate thrust. They now return to the cockpit to attach handlebars to a steering mechanism. The engine can be either a 2-stroke or 4-stroke, depending on the amount of power desired. They connect it to the drive assembly and protect that connection with metal casing. Once the engine has been bolted into place, they equip it with a radiator, an air filter, an exhaust system, and a waterproof box containing the electrical components. Then they connect the fuel tank to the engine. and cover the engine with a polyethylene hood to keep it dry. They install seating, including a rear bench that accommodates 3. Then the installer attaches 2 rudders to the fan duct. He links them with a bar so they'll move in tandem. These steering parts are made of marine-grade steel to prevent rusting. A quick check confirms the rudders are operational. The hovercraft skirt is made of the same material used on shoe soles, sturdy polyurethane nylon. They assemble the skirt to the hull in 65 different pieces. The worker loops each segment over a side bumper and secures it with a steel clip. He then attaches the bottom of each skirt piece to the little hooks on the hull. He uses plastic cable ties for this job, and there's a good reason. If the skirt becomes snagged on something, these ties will break and free that section. Then other parts of the skirt will balloon out to fill the breach and maintain the air cushion. And they also won't have to replace the whole skirt, just the section that's been damaged. After a final inspection, they take this hovercraft for a test spin. They check the steering and overall performance and enjoy gliding on air.